Hi. So I wanted to follow up my previous video with the design for an AI gateway, a simplified design, um, and actually bringing AI agents and AI gateway together. I wanted to really follow that up with an actual demo. So I put together a POC, which I think simplifies the way what the gateway looks like today. So let me first talk to you about agents. So what I've done is I've created a mock UI. And again, this is a mock UI. This will eventually make its way to GitLab as the agent UI itself. And so, this is just showing what's possible and just helping everyone visualize what we're talking about. So in GitLab, we'll be creating multiple agents, and each agent will have a purpose. So like there's a code generation agent here, an issues agent. There's an agent for DeoChat issues, and agents will be versioned. So you can see, for example, this issues agent has a number of versions here, right? So it'll always be like incrementing versions up, and each version will then be related to an LLM and to a model. So let me try to create an agent here just to show you what it looks like. So here I can specify the agent name. So let's say my agent. I'll specify an LLM, whichever one I'm going to use, and the model that's going to be used by that LLM. Specify some parameters like temperature. I'll specify the system prompt, and then I can attach one or more tools to this. So, for example, I have an Epic Reader tool, and have an intent. I have a Python issues tool. So I could add all these kind of tools to the agent, and then I could create a new version, publish a new version. I can also test the agent here by actually starting to type some text, right? So that's basically the agent. If I hit create here, I would have created a new version. And similarly, I can actually create tools as well. So tools is another core entity. And so the way you create tools is that you would specify a tool name. So let's say issues. Um, you specify whether that needs to be executed in Python or in Rails. So in the case of Python, it'll be executed like on the spot in the AI gateway itself. Whereas the Rails bit would be actually making an API tools call to the Rails monolith to actually execute the tool, right? We also need to decide whether the tool is a pre-processing tool or a response tool. So pre-processing tools will add stuff to the request when required. For example, I may need to pre-populate. I know that the user's on the issues page. I want to pre-populate the issue details before actually sending it out to the LLM, saving myself some time, right? Because if I made it a post-processing tool, the LLM would then need to say, okay, what's the issue number or whatever. So that so here in this case we're saving time by pre-processing, going and fetching details that we need to. Another example is intent generation could be a pre-processing tool as well, where we are deciding whether it's generation or completion. Another example is just like cleaning up any redundancies in the question, etc. So those are a number of pre-processing tools that we can execute. And then of course the response processing. This is after the response comes back from the LLM. If you want to run a few tools, you can do that, right? So that's type, and then module is exactly what you want to run after it's done. So for example, if it is Python code that you wanted to run, so you'd say AI gateway tools issues, and then the class name, right? So I could say issues or something like that, and that would then respond. That would then call this tool using this package. So that's very possible. And then the response template is what actually gets added. So after the tool is executed, what actually gets added to the prompt so that the LLM can actually see the results, right? So this again uses the Jenga templating language, where I would say, hey, I want to add, let's say, the issue ID, and I want to add the issue title, right? So you would use templating to actually add that in, and maybe some description saying here are the issue details, right? And something like that would then show up in the template. So when the tool is executed, we apply the template to the result of actually running the tool, and then that is then displayed, right? So I've already created two agents which are useful. So I've created this issues agent and this code generation agent. Both use different model. So the issues agent is using the Anthropic Haiku model, and the code generation agent is using Olama and the Code Llama model, right? And I've got a bunch of other ones as well in this example. So let me show you now the up um, my NeoVim to show you what that looks like. So this is the config for AI Gateway, and what you'll see is that we have a port, we have a GitLab URL, we also have an encoder, and this is really used for semantic routing and deciding what to do. So for now, I've set it to OpenAI, but this can really be set to any of the encoder classes. So if you want to use Cohere for encoding or anything else, you could just set it here. We have an observability section to set the tracing and logging and metrics. And then the important part here is routes. So routes are the various routes that we want to take for each type of request, right? So here I'm specifying the path. So if it's if anyone's hitting v1 chat, then there are a bunch of subroutes that can be executed depending on the reason, right? So I want to execute the issues agent if any of these utterances have been occurred. So, how would I fix this issue? Could you please summarize this issue? Could you please describe this issue, etc.? And even like the version number of the agent, that's important because each agent is version. So which version to execute, right? Similarly for code gen, I'm saying, hey, use this code gen agent if it matches any of these utterances, right? So write a Python program, I want to do code gen. Or someone says, oh, can you refactor this code for me? Then I want to use my code gen agent, model, and tools, right? So that's basically it. And you can imagine that we could use this for various things. For example, we go to a single version, but maybe we could split it, right? By looking at a dice roll or something, by saying, hey, for 40% of the requests we want to go to version 1, for 60% of the requests we want to go to version 2, etc., right? So you could set that up in your routes. Again, this is all in the AI gateway side and configuring that. Let me also show you how easy it is actually, the code itself. So it's quite simple. So all we're doing here is really loading the config, and then we're setting up our router for each route, right? And this is using the semantic router and deciding which encoder needs to be used and stuff like that. We're then just deciding what agent it is based on the routing. So we're actually calling the routes, and it's doing a semantic search to figure out, hey, this last message that came in, which subroute does it match, right? And so that's what we are doing here. So deciding the agent based on the subroute. And then here, what we're doing is we're actually fetching the agent config from GitLab. Now, I've just, this API actually doesn't exist, so I've just created like a mock API locally that fetches these details. But basically, the same details that we spoke about before. That's what's being sent here. And so this just fetches like the agent details from like the agent name, all the tools configured, the system prompt and stuff like that. The next thing we do is we add a system prompt to the request. So the messages that are coming in, we are sending the system prompt as well. And then we execute a bunch of pre-tools, right? So in my case, we just have one pre-tool, which is the issues pre-tool, which is searching basically for the existing issue, right? But it could be any sort of pre-tool. I'll show you what that tool looks like as well. So we are executing tools one by one, and then once the tools are executed, we just apply that tool template and we add it to the user's kind of last message content. And finally, we're using light LLM here to actually do a completion, right? So what's happening here is we're saying, light LLM, can you please complete it based on this model and these messages? And the best part about using light LLM here is that this could be a variety of different models. So this could be like an on-prem model. This could be like a it could be like hosted model like Anthropic, and the kind of the method is the same. You get a similar response, and it's kind of very uniform and very easy to write. Like in the existing AI gateway, we have hundreds of lines of code just to call different models, and we could save upon all that by just using something like Light LLM, which supports a variety of models using a consistent interface. Let me show you the what the request actually looks like first. So let me show you the request. So we've got messages in the request, so a list of messages. For example, the user may be on the page and say, "Can you summarize this issue for me?" And then we also send in context like the project ID and the issue ID. So this is some additional data that you send in, and this could be sent in from the IDE, from the chat UI, wherever, and basically sending in the additional information about what context that user currently in, and we use this to actually call in the tools, right? So let me show you the issues tool, for example, here, and you can see this issue tool is very simple. All I'm doing is making a GitLab API call to actually fetch the issues, and then just responding with that. So that's pretty much it. So the tools can be written as many as you want, and just placed in either Python or Ruby. And the Ruby tool basically just call a REST API and ask Ruby to run the corresponding classes, whatever, with the responses. The part that I haven't completed so far is the post tool. So tools which are run after the LLM response. So that part is not at the moment there in the POC. But that's pretty much it. So very simple. We decide based on the utterances what agent actually needs to be called. We then go and fetch config. We modify the system prompt. We run pre-tools. We call light LLM to actually fetch the response. We run post tools, and then we return the response. Right? Again, it was really quick to put this together. So let me show you this in action now. So I can go ahead and actually make a request. So I'm going to first use the issues example. So the solve issues example, if you see here, and I'm going to ask it to do. And this, if you saw, was going to Anthropic to Haiku. And if you see, I ran it. It actually gave me a response from Anthropic summarizing that issue. Because if you remember, the user's question was, "Please summarize this issue," and it used the Claude 3 Haiku model to do that. Right, so this is an example of one of the requests, and then to the same endpoint, which is API v1 chat, I'm going to send another request, which is for code generation, right? And let me show you what that was. So if you see this, it's just about, hey, can you please generate a Python program to print the first 10 prime numbers? And that's literally all there was. And so if I go and run that request, if you remember, we had configured that on the UI to use Ollama. And so this is going to go and hit actually code llama locally, and then it generated the Python program for me. Right, so this is actually the architecture that was described. This is actually a version of the AI gateway with that in action. Please reach out if you got any questions. I hope you enjoyed this. Thank you.